Okay, so I think by now we're ready to introduce looping or how to loop in C++. Looping also can be referred to as iteration or repeating a set of code. So we've seen so far sequential programming. So let's say you have a program that starts this way, you have some sort of declaration, you have some sort of an input here, maybe you have some sort of a process, then you have some sort of an output, and then what you have is an exit, right? So this would be a sequential program, okay? It goes from top to bottom, and so the flow is basically sequential. We've also seen when we have conditional programming. So for example, let's say we had a program and here, and again, let me remind you what these are. This is declaration, right? So these are declaration. By the way, this one here is start. And if you have a start, this here will be the end, right? So that delineates the beginning of the program and the end of the program. So typically we like to declare things, then we like to do some sort of an assignment. Then we like to do some sort of processing. And then we like to do some sort of an output to display the result after processing. Now, suppose now you had some sort of an input, but before you process, you may have had a question that led, if it's true, the answer to that question led to some sort of a process here. If it was false, it led to another process right here, right? This is an if-then-else statement. And then it will join here. So we know that as far as the flow is concerned, let's look at these arrows here. And again, these lines here are called flow lines, right? So this arrow here is called a flow line, right? So as we could see here, we could either flow this way or flow that way, depending what is the result of that question. And then maybe output this way and then end the program, right? So this would be a typical flow chart for an if-then-else statement. Good. So now what I'm going to do is put a flow chart together to show how to do repetitive or iterative coding, right? So let's say we have a start right here, okay? And let's say we've declared some variables, right? Assigned memory space for them. Some even may be initialized, okay? Let's say we had some sort of an assignment going on, and then we decided, based on the value that's in there, we're going to repeat a certain number of iteration until the condition for that question is false. So maybe you might ask a question here, just like an if statement, okay? And if it's true, let's go out this way. You're going to go ahead and process one way, and then you're going to check again. And notice here what I'm going to do. So I'm going to erase here and put what we call a connector. So basically you have an arrow this way, an arrow this way. So what it means is you're going to do something if it's true. You're going to come back and you're going to ask again, is it true again? If it's true, then you're stuck in what we call a loop. Only when it's false, then you exit the loop. You might do something else, maybe print out somewhere in here. It doesn't matter what you do there. What we're concerned with is this part right here, okay? So we could see that we have a condition right here, just like an if statement, that dictates if you're going to go inside the body of the loop. Just like an if statement, it will, if it was true, it will dictate you're going to execute anything in the true part or the true block of your if statement. If it's false, you're going to do something else. Okay? But here, you are controlling the flow, And you're going to stay in this loop until something happens. We're going to see that you have to have control over this condition. Otherwise, you're going to be here forever. That's called an infinite loop. So somewhere in here, right, we need to have some sort of a modification, some sort of an assignment to change the value of the variable that you're checking against. So let's put some sort of an input here or some sort of a process. So that variable could be changed either through the process or it could be changed through a new assignment. Okay? So that means, let's say we had a variable int a equals 0. And as long, and you didn't do anything to a here, so nothing happened here. But as long as you say a equals 0, if it's true, you're going to keep going this way. But here you might be asked to enter a. So if you enter 0, you're going to remain in the loop. If you enter 1 or -1 or any value other than 0, then it's no longer equal to 0, right? So let me just remove that question mark to show you again what would have been the condition here. You would have said a equals 0 question mark, right? We know initially we've primed the loop. So when you do something like this, it's called prime the loop. We know we're going to use that because we want that true condition at least once to go through the loop. Here is what we call the condition. So this is what you evaluate. Is a equal to 0? True. Then you're going to go in here. This here allows you to alter the variable that controls the loop. So I like to call this process right here, or this input right here, either one, depending on if this process here affects a, let's say a equals some formula. So either one of them is what I call loop control. Okay, depending on which one you prefer to, or which one you decided will alter the value of a when you come back and evaluate again. If you have no control over the variable a, which is at the core of evaluation here, then you will be looping forever since a will always be equal to 0. So you need to have some sort of control, right? To alter the value of a. So you have a way out. Now, if you keep a at 0, that's fine, if that's what the intention is. And then you're going to keep going and loop again. You want a equals 0 again? Great, it gets reevaluated here. Okay, and as long as it's 0, the condition yields a true. You are going to loop again. Now, let's suppose this time a is no longer 0. Great, what's going to happen now is the condition will yield a false, and you continue on with your program to the end. Okay? So, again, if you're in a loop, you are going to repeat a set of code or a set of instructions right here, and that could include your loop control. It could include other things, but you definitely need at least one of them to control the loop by changing the variable value that you use to evaluate your entrance into the loop or your exit to the loop. Okay? So this here would be what we call a while loop structure. So this is a while loop structure. So if you're going to do a while loop structure, always make sure that you first prime the loop, which means you need to assign a value to the variable that you use for the assessment prior to entering the loop. Okay? That allows you at that stage to at least have a chance to have a true result out of that condition. Then you need some sort of a loop control to give you a chance to get out of the loop, okay? All right, so 3 items here. Prime the loop, loop condition, and loop control. And these are elements of a while loop structure. Again, prime the loop, number 1. Number 2, you need to write your condition. And number 3, make sure that you have a loop control within your loop to be able to get out. There are a couple more structures actually for looping, and we will see next time the do while loop and the for loop. So these are very popular in terms of in C, C++, Java, many languages as a matter of fact. But the while loop is really a good construct, basic construct to start with, to learn how to manipulate the outcome for a loop based on some variable's state that you've already primed before you assess the condition, and then you were able to control the flow through what we call a loop control. So for the next video, we're actually going to do a while loop structure, and we're going to code that in C++, and we're going to review some of these concepts that I just laid out in here. I will see you then.